Grin for Bitcoiners. Privacy and fungibility. There are three main properties of Grin transactions that make them private. 1. There are no addresses. 2. There are no amounts. 3. Two transactions, one spanning the other, can be merged in a block to form only one, removing all intermediary information. The two first properties mean that all transactions are indistinguishable from one another. Unless you directly participated in the transaction, all inputs and outputs look like random pieces of data. In lingo, they are all random curve points. Moreover, there are no more transactions in a block. A Grin block looks just like one giant transaction, and all original association between inputs and outputs is lost. Scalability. As explained in the previous section, thanks to the Mimblewimble transaction and block format, we can merge transactions when an output is directly spent by the input of another. It's as if when Alice gives money to Bob and then Bob gives it all to Carol, Bob was never involved in his transaction is actually never even seen on the blockchain. Pushing that further, between blocks, most outputs end up being spent sooner or later by another input. So all spent outputs can be safely removed, and the whole blockchain can be stored, downloaded, and value verified in just a few gigabytes or less, assuming a number of transactions similar to Bitcoin. This means that the Grin blockchain scales with the number of users, unspent outputs, not the number of transactions. At the moment, there is one caveat to that. A small piece of data, called a kernel, about 100 bytes, needs to stay around for each transaction, but we are working on optimizing that as well. Scripting. Maybe you've heard that Mimble doesn't support scripts, and in some way that's true, but thanks to cryptographic trickery, many contracts that in Bitcoin would require a script can be achieved with Grin using properties of elliptic curve cryptography. So far, we know how to do multi-signature transactions, atomic swaps, time-locked transactions and outputs, Lightning Network. Emission rate. Bitcoin's 10-minute block time has initial 50 BTC reward cut in half every 4 years until there are 21 million Bitcoin in circulation. Grin's emission rate is linear, meaning it never drops. The block reward is currently set at 60 Grin with a block goal of 60 seconds. This still works because 1. Dilution trends towards 0, and 2. A non-negligible amount of coins gets lost or destroyed every year. Frequently asked questions. Wait, what? No address? Nope, no address. All outputs in Grin are unique and have no common data with any previous output. Instead of relying on a known address to send money, transactions have to be built interactively, with 2 or more wallets exchanging data with one another. This interaction does not require both parties to be online at the same time. Practically speaking, there are many ways for two programs to interact privately and securely. This interaction could even take place over email or signal, or carrier pigeons. If transaction information gets removed, can I just cheat and create money? No, and this is where Mimblewimble and Grin shine. Confidential transactions are a form of homomorphic encryption. Without revealing any amount, Grin can verify that the sum of all transaction inputs equal the sum of transaction outputs, plus the fee. Going even further, comparing the sum of all money created by mining with the total sum of money that's being held, Grin nodes can check the correctness of the total money supply. If I listen to a transaction relay, can't I just figure out who they belong to before being cut through? You can figure out which outputs are being spent by which transaction, but the trail of data stops here. All inputs and outputs look like random pieces of data, so you can tell if the money was transferred still belongs to the same person, which outputs is which output is the actual transfer, and which is the change, etc. Grin transactions are built with no identifiable piece of information. In addition, Grin leverages Dandelion Relay, which provides additional anonymity as to which internet um, to which IP or client the transaction originated from, and allows for transactions to be aggregated. What about the quantum computer Gedon? In every Grin output, we also include a bit of hashed data, which is quantum safe. If quantum computing was to become a reality, we can safely introduce additional verification that would protect existing coins from being hacked. How does this how does all this magic work? Click next below. Preface. The following three-part series is intended for those who wish to understand what goes inside Mimblewimble and Grin. We try to make this objective more accessible by going through the cryptographic primitives required to know first, without diving into proofs and specifics. Once those are in order, we connect everything, explain how we connect everything, explain how Mimblewimble works.